Here we are looking at symmetry of functions. And from what we see here, a graph can either be even, odd, or neither. So an even function, so a function that is symmetric about the y-axis. For example, you can see this function here is symmetric about the y-axis. And if a function is even, from algebra, if you plug in negative x, it's just going to give you f of x. And here is an example. And then odd function is the one which is symmetric with respect to the origin. And you can look at this graph here. And if these are the conditions, it has to satisfy algebraically. If you plug in negative x, then you get negative f of x. You can factor the negative outside and you're left with f of x. And here is an example here. So here we have an example we are going to do. So we are told to determine whether it's an even function. So we have a clue here. If I look at it graphically, I can see it's an even function, but I need also to show it algebraically. So, and the way I'm going to do that, I'm going to do f of negative x, plug in negative x, and this will give me negative 2 negative x squared plus 5. And that gives me negative, that will give me negative 2x squared plus 5. So, and what I see here, so this is f negative x. When I plug in negative x, I just get the same function I had before. So that means f of negative x is equals to f of x. So that's the definition of even. So I'm going to say even. So this one we're supposed to check the same thing. And let me look for some clues. I see the exponent is 3, which is odd. The other exponent, so this exponent is odd, the other exponent is 1. So here I might be dealing with an odd function. And I can also check here, it's symmetric about the origin, symmetric about the origin. So let me work it out here. So I'm going to do f of negative x. And what do I get? 2. Then I get negative x cubed minus 5, and then I get negative x. And when I simplify that, I'm going to get 2 negative, I'm going to get negative 2x cubed, and this is going to be plus 5x. And note this is the same. This is not the same as f of x, so I know this is not an even function, but I can factor out the. Let me factor out the negative. So what am I left with? I'm left with 2x cubed minus 5x. And see what is inside here looks like f of x, what I had at the beginning. So that means whatever I have here, I can be able to write it. This is equals to negative f of x. So what I have here is f of negative x is equals to negative f of x. And that is the definition of an odd function. So I'm going to say here it's an odd function. And you can see from the graph, it's actually an odd function. Okay, the next one here, I can examine the graph and see what's happening. See here, I can see it doesn't even go through the origin. So it's not, so I don't see symmetry about the origin. And I also see the degree here is odd. This one is even. So I need to check this one using algebra, but I'm thinking it may be neither. So f negative x is equals to, so this is going to be 2 negative x cubed, and this is minus 4. This is negative x squared minus 2 negative x, and then plus 3. And what do we get? Negative 2x cubed, and this is minus 4x, and then plus 2x plus 3. And I see this doesn't look like what I have there, so I can be able to say here f negative x is not the same as f of x. So I know it's not odd. I mean, it's not even. So here, not even. I know that for sure from that. Then the next thing I'm going to do, let me do negative f of x, and then I'm going to see whether it's equal to what I have gotten up there. So it's going to be negative 2x cubed, and this is plus 4x squared plus 2x, and then this is equals to minus 3. I just multiplied f of x by negative all through, so that's what I get. And see, this is not the same as, I can write here, this is not the same as f of negative x, which I had gotten up here. It's not the same as this. They are not the same. So I'm going to say here, because negative f of x is not equal to that, so I'm going to say not odd. So I'm going to say here neither.